Good morning everyone. So today I'm going to explain that foundry and forging lab experiment. So in that I'm going to explain that forging experiment. So before going to conduct that experiment, first we should know that the meaning of that forging. Forging is a type of manufacturing process in that shaping of a metal into our desired shape and size with an application of that compressive force or hammering. In this forging experiment, first experiment it is that aim of that experiment is to prepare a model as per the given sketches. So these are sketches in that model we are given, that is that 100 mm length of that workpiece and 16 mm diameter of that workpiece. First we need to calculate that volume of that workpiece. We all know that cylindrical volume of workpiece of the volume is given workpiece volume is 5d square by L. D is the diameter of that workpiece and L is the length of that workpiece 100 mm. Finally you will get that volume volume of the given workpiece is 20106.06 mm cube. So later after hammering this workpiece, finally we will get the desired shape and size of the specimen. So to getting the specimen, we know that square, round to square model, the square dimension it is 12 by 12. So while hammering to the 12 by 12 side, that length of the workpiece it may vary. We need to calculate the length of that workpiece, that is x. How to calculate that x? Here you can see that first before calculating that x, while hammering what will happen? There is a chances of that scaling. Scaling it means that some of the surface area of that material it may chances of removing. So that we call it a scaling. We are assuming that 4% of losses due to that scaling operations. See, we need to assume minus that 4% in that volume. How to? Is that VA is equal to 1 minus 0.04, that is that 4%. 0.04 it means that 4% into that given volume. So your VA will get 19301.86 mm cube. So with the help of that volume VA, we need to calculate that length of the finished specimen. We know that here the length of the required specimen, that volume of the specimen is VA finished model, volume of the finished model equal to S square into that x. S is the side length of the workpieces. Volume is equal to S square into x. X is that unknown. We need to calculate the length of that workpiece, that is x. VA, we know that 19301 equal to 12 square. 12 is that S is the 12 side length. 12 square into that x is that unknown. And finally 19301 divided by 12 square is equal to x. That final value of x is 134 mm. So later we will get that value of that 134 mm. So measure the this is the way to calculate the forging operation. These are the major tools we are using. One is that anvil, hammering, and major tongs we are using, and flatter to finishing the surface of the workpieces, and the swage block. That purpose it is used to giving a required shape. It may bending like that. So these are the major tools we are using. And is that flatter. So after forging operation, it's used to finishing that model, finishing to provide the good surface finishing. And these are the major tongs. It's used to hold that workpieces. Here you can observe it's in that round shape. When that workpiece it is in that round, you can easily hold with the round tongs. If it is in that flat, we are using that flat tongs. If it is in that alloy tongs, alloy workpieces we can hold. If it is in that round cases, we can use the round tongs. And also here you can observe that chisel. Here is that cold chisel. There are the two types of chisel majorly in that forging operation. So that is cold chisel and hard chisel. In that forging operation, we are using that hard chisel. Hard chisel, how to identify that hard chisel? That angle of that chisel, angle is very less. Because of that, while forcing, while marking that operation, we need that less force. It can withstand that less force in the hard chisel. That angle it will be very less. And this is that anvil. It used to hammering that workpieces on the anvil. This is the on part. The total weight of this anvil around nearly 100 kg. And this is the swage block. You can observe the swage block here. Different types of cavities are there. Round and square and rectangular cavities are there. It's used to different kind of operations. Suppose if it is in the rectangular workpieces or round workpieces or square workpieces, we can place it easily in the swage block. And usually this anvil placed over the sand particle, because while hammering what will happen, it's getting vibration. So to avoid that vibration, we need to place that anvil over the sand in the container. Is the given workpiece model. So we already calculate that given workpiece volume also. So that is that furnace you can observe. We need to place that workpiece on that furnace. We need to wait 1 or 2 minutes for when that material, when it comes to that red hot condition, we need to bring it over that anvil. So when it comes to that red hot condition, when we apply that compressive forces, that material it will get easily deformed to our required shape and size. Now we can observe that material it is in that red hot condition. We need to bring it over that anvil for. So now we need to apply that compressive force over that workpieces. It will get easily deformed to our required shape and size. With the help of the tongue, we need to hold that workpieces. Now we can observe that material almost it is in the finishing stage. By using that flattener, we need to finish that model. It will provide that good surface finishing or that surface. Now you can observe that material is in that finished condition. Now we need to measure that length of that workpiece. Around it will be almost it is 134 mm. This is the way to conduct that forging operations. Thank you.